Hi everyone, it's Sam from Over Renewables and I'm going to take you through our latest EV charging project out here on the outskirts of York. We've installed a 7 kilowatt single phase Zappi, which is just behind me here, on our first ever Myenergi Pedestal. It's a little bit different this one though, as we've installed a large submain to an outdoor building in preparation for that building being converted. But I'll take you through all of that in the course of this video. Okay, so let's roll back the clock when all the hard work was going in, pulling the cables in, putting the ducting in, and we'll show you how we've installed that. Okay, so let's start right at the beginning. How did we connect all of this into the customer's supply? What we've done is we've put a little two-way load and consume unit in with a 50 amp supply out to this outbuilding. We've then also ran a Cat6 external grade data cable back to the house as well. That little data cable will act as our CT clamp extension cable. That allows the Zappi to monitor what is happening at the main fuse position. That helps us protect that main fuse if this Zappi was charging the vehicle and they had high electrical loads in the house, then the Zappi can downrate its charge based on the information it's gathering from that hardwired CT clamp at the mains. We've split the main tails, which has allowed us to take a supply into our little two-way board to get all of this working. Now we've got that little consumer unit installed in the house, the next step is to install our 50 amp submain to this outbuilding. A lot of digging, a lot of pulling cables, but we're very lucky the customer pre-dug the trench for us, so all we had to do was lay our ducting in and put our cabling in place, and they even backfilled it for us. So we were spoiled on this job with the customer, and he's done a fantastic job covering it all back over. But let's have a look at how we installed that cable. Right, so we're cracking on with the install now. The customer's dug us this fantastic trench to save us a lot of back-breaking digging. Inside that trench we've then put an 80mm duct, which has got a 16mm 3-core armoured cable within it. Now, a lot of people will be looking at and thinking, why have you installed a 16mm 3-core? That is massively oversized for a 7 kilowatt Zappi, and it is, absolutely. But if we move along here, I'll reveal why we've put a 16mm in. This is the ducting all the way along here. Along with this, we've also installed a Cat6 external grade internet cable, so that goes into the router just on the back of there, and that's also in its own ductwork. All of this, the 16mm and the internet cable, they all go back to that outbuilding that you can see just behind me there. Now, in that outbuilding, plans are to possibly renovate that in the future. So what we've said is, rather than putting in a 6mm or a 10mm armoured cable just to supply the Zappi, why not spend a little more and put a larger 16mm 3-core in that will give that building plenty of capacity. Now, doing that means that this trench doesn't have to be dug again. So within there, we've got a little distribution board which will supply the Zappi circuit, so 32 amp circuit for the Zappi. It'll also supply a socket circuit which is running a network switch for the internet. Also the Myenergi hub as well is supplied from that network switch and that socket circuit. So that will then connect the Zappi online. So by putting this infrastructure in now, it means that no matter what happens with that building, it's got a very large electrical connection. So if it turns into an Airbnb building or a gym or whatever, it's got that supply in already. And also it's got a Cat6 internet cable, which will provide it with a really good internet connection up there as well. So no matter what happens, it's got a good internet connection. So when all this goes back down and is all put back together, that's it for the trench. There's no more trenching required. So I'll take you up there and show you further up the driveway. So we're up where the charger's going now, you can see it just here. So we've got the Myenergi Pedestal and the Myenergi 7 kilowatt Zappi. So it's the first time we've used the Myenergi Pedestal, and that is sat on an EV block. So it's the first time we've used the pedestal and the EV block together. It's great. We're really happy to use both of those together now. You can see here we've got the blue ducting, so that comes up, and this one comes from the garage. So that has got the Doncaster cable EV Ultra SWA, so it's still an armoured cable, and it's got a 6mm live, neutral and earth, and then a Cat 5 cable built within it. So the reason that we're using that is that it's an armoured cable, so it's a lot better to go in the ground, protected by the armourings, but it's also got this Cat 5 cable in, which will allow us to connect hard wire and connect the grid CT clamp back in the house. So that grid CT clamp will monitor what the home is using, and therefore we can add some grid protection onto it. So we can set within the Zappi, don't allow the main supply to breach 60, 80 or 100 amps, depending on what our main fuse size is, and we can connect that within the garage and feed that back down this Cat 5 and into here. So from the house, we've got a Cat 5 cable, which is going to be connected to the CT clamp. That goes into the garage. Then within the garage, we then connect the two pairs of the Cat 5 that comes from the house to this one in the EV Ultra, and that comes up and it'll hardwire into the Zappi. We could have used a Harvey, and that would have meant we wouldn't have had to run that Cat 5 cable in, but we always prefer to hardwire things if possible. The Harvey is a very good device, and we really do love that device, but if we can hardwire it, it brings things down to basics, and it's a hardwired connection, which is just always more reliable. So that's what we've got. So this EV Ultra is going to go underneath this EV block. It'll pop out at the bottom of that white cover, come up behind that white cover, and then gland into the Zappi and supply the Zappi with power. Simple as that. I'm going to show you the EV block now. So the EV block is a pre-cast block, and that's made of recyclable materials, so it does its little part for the environment as well. The Zappi sits on this pedestal here, and then if I just lift this Zappi off, just lean that back there for a minute, you can see we've got this plate here, which comes with this hole already drilled into it, the bottom of the pedestal through this plate, which is where we're going to bolt this pedestal to this plate. This plate lifts up and comes off, so we can effectively now fix this to the bottom of the pedestal, and that will then sit onto the EV block. The EV block comes with some threads already pre-cast into the EV block, so this will literally just bolt down onto the block. So that makes it really easy for us to connect the pedestal to this block. So what you can also see is we've got these arches under here. So we've got an archway under here, which is where we're going to bring our cable in, but there's an archway on every single angle. So that means that if we were having, say, 5 of these in one long row, we could bring ductwork basically straight through, just cut the top of the ductwork to bring the cable out at each individual point, which make commercial installs a lot easier, domestic installs, just everything a lot easier. So with that in mind, we can now run our ducting underneath, so we can always get access to the ducting in the future, and bring our cable up through the bottom of this plate here. So it'll pass through here. That then passes through underneath this, through this pedestal, up and connects into the Zappi. So that is the next part of our task, really, is getting all of that put together. And then once all of this is put together, we can make sure that this is bang on level, and just finally put some concrete around the outside just to fix it in position and set it, and then we can leave that to set, and then after that all of this can be backfilled with soil, and then over the top we're going to backfill it with gravel, so that the customer can't actually see this bottom plate. All they see is this Myenergi pedestal rising up out of the ground. So that's what we're on with, and we're going to crack on. So we're out in this outbuilding now. One of the parts of this job was to put a large submain to this outbuilding. In the future, this customer's planning to renovate this and maybe make it into an Airbnb kind of thing. So we said, well, whilst you're digging the trench, why not put a large submain in, an oversized submain for the Zappi that will also allow you to add the sockets, the lighting, the cooking, everything else that you're going to need here, and save having to re-dig that trench. It obviously added a bit of cost to the job, but in the long term, it's going to reduce the costs of this job. So what we've actually got here is we've got the submain coming in to this building. Behind this boxing here that we've put in, we've actually coiled a bit of this cable, so there's a couple of meters of this submain still behind here that will allow them to change the position of all of this in the future if as part of the renovation works. So the submain comes into this header trunking here and then supplies another little Luden consumer unit just here. So within this, we've then got our main switch, our RCBO for our charger, and then an RCBO for our sockets, which are just below. Now, with this system, this house is on what's called a TT earthing system. That means that there's a main earth rod. The earth isn't supplied by the main network, it's an independent earth. That means we've got to do specific things to make sure this system is protected and up to current regulations. At the mains incoming position in the house, we've got a Type S 100 mA RCD. That allows us to protect our distribution circuits. We've then got, in here, we've got the two 30 mA RCBOs, and that allows us to protect our final circuits. So that's why we've got what we've got, and we're not too worried about exporting the earth on this because it's already on an earth rod system. To electricians watching this, they'll know exactly what I'm talking about. For anyone that's not an electrician, don't worry, this is all part of our job, so we know what we're talking about. So as we move down this board, we then installed two double sockets. One of these double sockets is just for the customer's use, to power the tumble dryers and the freezers and things that are in here, but this one is quite an important one. Here we've got the Myenergi hub, which is connected to the Zappi and connects the Zappi online for the customer's app. But then we've also got this little network switch just here. And from the house in the trench, we've ran a second Cat6 data cable is for the main internet connection. So that comes into here and then out of here into our hub. So you can see it just passes through the boxing here. So it's all nice and neat. Now that was another part of us planning to keep this building future-proof for when they renovate it, because now this little building has got a hardwired Cat6 data cable, which means that they don't have to dig a trench in or anything like that for internet. They've got that in this position already. So on this job, we've made sure that we've hardwired all of the CT clamps that make this Zappi work. To this building here, what we've ran a Doncaster EV cable with built-in Cat5. A couple of reasons for that. One, it maintains our hardwired CT clamp from the mains, as it's got an inbuilt Cat5 cable, so we can hardwire that grid clamp that is right at the mains that's protecting that main fuse. That's on one pair of the inbuilt Cat5. On the second pair of the Cat5, if we want to, we can add a solar CT clamp. As part of this renovation of this building, the customer's thinking of integrating solar, which then the Zappi will be able to make use of, and it'll help them reduce their energy bills for charging the car and everything else. And on the third pair within that Cat5, we can actually monitor this little distribution board, or the distribution board that ends up getting installed when they renovate this building, if they do ever renovate this building. And that third CT clamp is quite a crucial one, because that one will allow us to protect the sub-main supply to here. So for example, if the car's charging from here, they're cooking from here, they might have an electric shower from here, we can make sure that the supply that is supplying this building doesn't trip. So that 50 amp supply that comes into here, we can set a local monitoring limit to make sure that the Zappi, when it turns on, it considers the main fuse limit of 80 amps at this property, the local sub-main limit of 50 amps to this property, and also the solar, so they can put all of the solar information if they decide to get solar on that. So we've really put a lot of thought into this install to make sure that it's as future-proofed as possible. So let's talk about the parts that as customers and passers-by you don't see, but as engineers we love, and is kind of sometimes the more exciting parts of the jobs. So on this job we've installed this beautiful Myenergi Pedestal. So we've got this cable guard here which bolts in, and our cable, our Doncaster Cables EV Ultra, runs through the middle of this, which hides the cable and is glanded into the bottom of this charger. So now we have got the main star of the show. We've got the Zappi here. So this is, you can see it's a white 7 kilowatt tethered Zappi. So with the Zappis you can get 3-phase Zappis, so 22 kilowatt ones, and these pedestals actually come as standard holes for 2 Zappis. So if, for example, in the future this customer decided that they wanted a second Zappi, this could literally be lifted and spun round to reveal a second fixing position for a Zappi. The Zappi itself, now if you've done some research into EV charging and the Myenergi Zappi, you'll probably know a lot of this, but for those of you that haven't, this should be hopefully really valuable. So the tethered Zappi has this Type 2 tethered plug onto it, which has 6.5 meters of cable. So that wraps nice and neatly around the outside of the Zappi, and it has this holster that is positioned backwards so that any water that comes down runs off the plug and not into the plug. So every little bit of this has been thought about. It's completely waterproof, so the fixings through the back are all captive, so we've got no issues of water getting into it. They've got waterproof plugs as well, so it's a really well thought out piece of kit. We've then got these touch buttons here along the front, which allow us to go menu, up, down and enter. Also, these are our numbered buttons for if you wanted to set a pin onto this. So if you were concerned that the charge point might be used by someone that shouldn't be using it, then you can actually set a pin into this so that before it charges, before it unlocks, before it does anything, it will require a pin code to be put into it, which is really good from a safety point of view. So now if we have a little look at the actual screen itself, I'll take you through what you can see when you come up to a Zappi. So here we have the Zappi's screen itself. I'll take you through what all these icons mean now, so you know exactly what you're looking at if you were to get a Zappi or to see a Zappi. You can see here, right in the middle, you've got the house. And the actual expression of this house changes depending on how your home is using the power. So you can see at the minute, this home here is buying in 300 watts from the grid. So there's no microgeneration on this job, so there's no solar or wind or anything like that. So everything this home uses currently is being bought in from the grid. So the house, unfortunately, is always going to look a little bit unhappy. However, if during the renovation they decide to actually get solar PV on that outbuilding, then we've got all the infrastructure in place ready to monitor what the solar is generating. So that would then populate this little line, as it is here, with power that the solar is generating and feeding into the house. So take the example of the solar is generating a kilowatt of power, the home is using 300 watts of power, it would show an export of 700 watts going back to the grid, and we'd have a nice big smiley house in the middle because it is generating all its own power. We've then got, moving down, we've got EV disconnected, so that shows us the status of the charger. So this top part is a little bit more of like a building energy system, whereas now we're starting to get into what the charger is doing and its functions and how it actually operates. So we see there EV disconnected. So if the car is actually plugged in at this point, then there's a problem. But at the minute we've got the charger in the holster, and so it's ready for the car to roll up and start charging. We've got the time and the date there, which helps us for error codes and to work out what's happened when and schedule charges and things like that. We've then got these two little pictures. So we've got the Zappi here, and then we've got the car here. If we had the car connected, this cable here will be linked into the car itself. We've then got, moving down, we've got fast. That is the mode this charger is set to. So fast mode, I'll take you through what these modes mean. Fast mode is looking to charge the car as quickly as possible, or as fast as possible, as the name alludes to. That'll give the car up to 7 kilowatts of charge. The car always has the final say. So for example, on this car, the car will charge at around 3.5 kilowatts. But if the customer is to upgrade the car, this charger will allow up to 7.4 kilowatts of charge. We've then got a little kilowatt hour counter here. So that is the amount of units, so kilowatt hours, that the car has received during the last charging session. So when the car was plugged in, to when it was either unplugged, or to when it achieved a full charge. You can see exactly how many kilowatt hours has been sent into the vehicle. If we then move through the other charging modes, we've then got eco mode. So eco mode is kind of a halfway house between a full green charge and a fast charge. In eco mode, as soon as you plug the car into the Zappi, it will start charging as long as the car is wanting charge. It will charge up with the magic number of 1.4 kilowatts. 1.4 kilowatts is the minimum amount of charge that the car can accept. So what eco mode does is it instantly starts to trickle charge the vehicle with 1.4 kilowatts in preparation for the solar to kick in during midday to then boost the charge with the solar power. Because what it doesn't want to do, it doesn't want to charge the vehicle up in a couple of hours in the morning when the solar isn't very strong, to then see loads of solar going back to the grid. So the eco mode trickle charges the vehicle in preparation for the solar to get to its peak generation during midday, late morning, early afternoon. The next mode is Eco Plus mode. Now this is a mode that you can configure in the app or on the Zappi to set a minimum green level. So if we remember that magic number of 1.4 kilowatts, that is the minimum that the car will accept. So if we work with that 1.4 kilowatts for a minute, if we set the green level to 100% in this mode, then the car will not start charging until there is a minimum of 1.4 kilowatts going back to the grid and effectively wasted. The Zappi will then see that there's 1.4 kilowatts going to waste and go, that's the magic number, I'll start charging the vehicle with 1.4 kilowatts. If the solar then starts to increase 2, 3, 4 kilowatts, depending on the size of the system, it will ramp up the charge to match that as well. If you had quite a small solar PV system and struggle to achieve 1.4 kilowatts, then what you can do is you could set the Eco Plus green level to 50%. And that would mean that the car wouldn't start charging until you had a minimum of 700 watts going back to the grid from the solar. And that would mean that the car would buy in 700 watts from the grid and use the 700 watts that the solar was producing. If the solar started to ramp up its generation, it would then decrease the amount it was buying from the grid. Always prioritise and use the solar PV power first before it buys anything in from the grid. So as a minimum, as an end user, this is kind of everything that you need to look at and work to get your Zappi to start charging your vehicle. If you don't have solar and you don't want solar for whatever reason, maybe your roof isn't a good roof for solar and things like that, then putting the Zappi on fast mode and plugging your vehicle in, it will just act as a normal charger, but with the safety and the reassurance that it's monitoring the grid to make sure that you don't blow that main fuse or any sub fuses, as I've explained previously. If you're an electrician watching this, then this is where it starts to get a little bit more interesting. I'm not going to go too far into this. We might do another video on the electrician side of things, but if I go into the menu, we've got loads of other bits of information here. We've got charge log, event log, so we can see exactly what's been happening with the system. We've got readings, so we can see exactly what the home is importing, what the temperature of the unit is, the current charging current, which obviously is 0 at the minute. There's an endless amount of information here, so I'm not going to go through all this now. Got information, so we can see loads of serial numbers and other bits. We can see what devices are linked, so in this situation we've just got the hub that is linked. Charge settings, so this is where we can set the Eco Plus settings. So a lot of this is a lot easier on the app, but we can go into here and we can actually set this minimum green level. So at the minute it's set to 50%. So that would mean that the Zappi would start charging at when it saw an export of 729 watts, and it would stop charging when it saw an import of 700 watts. We've got manual boost. So here we can tell the Zappi how many kilowatt hours to send into the vehicle. All the chargers out there don't know exactly how many kilowatt hours is already in the electric vehicle. So all it can do is monitor the amount it's putting in. So what we can do here is we can say, right, I know my car is a 60 kilowatt hour battery, a 60 kilowatt hour model car. And I know that I'm around about 50% charged. So if I want to get that to 100% and via a boost, I can go to that and select 30 kilowatt hours, which will top it up to around about 60 kilowatt hours. So that's an easy menu here to put the boost into. But again, all of this can be done on the app. Smart boost, so this is a little bit different. We can set here at what time we want the vehicle to have received an amount of kilowatt hours. So to work through why that is important, let's take the scenario of you arrive home on a Friday night, you're staying in all weekend and you've got solar. So you want to know that the solar is going to charge the vehicle as much as possible, but you also know that come 7 o'clock on Monday morning, you need that vehicle to be 100% charged to get you to work. You can set a smart boost so that the charger knows that at 7 o'clock on Monday, you need that vehicle to be 100% charged, and to get it 100% charged, it needs to have received 60 kilowatt hours. You can set all of that in here or in the app, and it will sit there on Eco Plus mode, charging up, trickle charging up on the solar that's available. But at the last minute where it has to start charging to achieve that 60 kilowatt hour total full charge, it will kick in and buy the rest of it from the grid. So that gives you the peace of mind that you can set it to Eco Plus mode, 100% green level, and it will trickle charge the vehicle just with solar power until it has to start charging with power that it buys in from the grid to allow you to get to work on Monday. So it's a little peace of mind thing there. Other settings, we've got time of day, display and sound, so we can change the display. If you've got a wind turbine, we can change the solar to a little wind turbine. We can add the lock function there, we can download the latest firmware, and then we've got advanced, which is more for the installers out there. So to come back out of that, that is kind of it for the Zappi. So throughout this video, I've talked about future-proofing and what we've done to future-proof the outbuilding and everything else. But another key part is we've chosen equipment that will allow expansion very easily as well. So for example, if this customer wanted a second Zappi, we could either put another Zappi on the back of this pedestal here, or if they wanted another Zappi in a different location, then we wouldn't need to install another hub, a load more CT clamps, anything like that. All we would need to get is we'd need to get the Zappi a supply and it be within range of connecting wirelessly to this Zappi. What we can set up then is a master and slave protocol. This is and would be the master of the system because that receives all of the information from the grid clamp, from any solar, from any little subboard monitoring, anything like that. We would then set any subsequent Zappis up as slave units. And all that would happen there is the master would regulate what the system as in total was seeing from the grid, from the solar, and relay all that information to the other Zappis. They can then do load balancing. So if there was 2 vehicles charging at 7 kilowatts, but then suddenly there wasn't enough for 14 kilowatts of load, then the master Zappi would then regulate the load between the two and ramp the charge down until that power was then available in the house. That might be an electric shower turns off or an electric oven or a hob or something like that we all have. So as part of future proofing, and something that we always consider is, right, okay, the customer wants this now, but what are they going to want in 5 years? Because the last thing we want to do is dig another supply all the way back to the house and have to put a new internet cable in, new CT clamps and everything like that. So sometimes spending a little bit more on equipment that is flexible and will allow easy additions is well worth it and can save you in the long run a lot of cost. We're not a company that wants to compete with others that are selling really cheap equipment and things, which works for them and that's fine. But for us, we want to set a standard that we want to fit good equipment at a fair cost for the service that's received. So that's what we've done here, and that's what we are doing across the country. So there we have our latest EV charging job with the Myenergi Zappi on a Myenergi pedestal using the EV block and Doncaster Cables EV. I hope you've enjoyed our latest EV charging video on our latest project out here on the outskirts of York. We love the Myenergi Zappi, and anyone that follows us on our social medias knows we go on about the Myenergi products, but they really are top class. Now that we've done our first Myenergi pedestal as well, we're just in love with that pedestal, how it looks. It just really complements the Zappi and makes installation so easy. Along with the EV block, which allows easy installation for us as electricians to mount the EV block and mount the pedestal to that EV block with a chamber to pull cables through, just makes the whole thing an absolute dream. So I hope you've enjoyed it, and drop any questions, comments, likes, please subscribe, and we'll see you on the next video.